Assalamu alaikum wa rahmatullah. Hi everyone. Today we're going to discuss about probability of independent events. So in this case, I'm going to explain to you about what is the meaning of the independent according to these situations. Let's say that we have two events, event of A, which is the experiments of the flipping a fair coin, and we have an event B, which is the number obtained when a pair dice is rolled. So if you're looking at these two events, we can see that this is actually unrelated to each other, whereby when we obtain a hit, when we flipping a coin, will not be influenced to the outcome of the dice. So therefore we can say that these two events as independent events. Okay, from the probability rule of conditional events, okay, we're supposed to have PA given by B, if you still remember the rules of conditional events. Okay, so the formula of PA given by B is equals to PA intersect by B dividing of PB. Those, when we do a cross multiply product, we're supposed to have PA intersect by B is equals to PB multiplied with PA given by B. Okay, then according to these definitions, if let's say that we have A and B are independent events, it means that the outcome of one event does not affect the outcome of each other. Then we can say that if we have a conditional event such PA given by B, okay, such PA given by B, so we're supposed to have, this is actually equivalence to probability of A. And the same thing the other way around, if we have probability of B given by A, this will be equivalence to PB. Okay, those, when we would like to find the intersections between two events of A and B, so this will be equivalence to PA given by B times PB. Then we know that if let's say that these two events are independent, this will be equivalence to PA multiplied with PB. In other words, when we have a probability of A intersect by B, this will be equivalence to PA times with PB. If let's say that we have events of A and B are independent to each other. So the same thing when we have a complement of the events such that when we have a probability of A complement intersect by B complements, so the same rules that we're going to apply here, whereby when we know that these both events are independent to each other, then we can say that probability of A complements will be multiplied with probability of B complements for their intersection. Let's start with the first example. Suppose two events A and B are independent, given PA equals to 0.4 and PB equals to 0.25. Calculate PA intersect by B, PA union by B. So now we know that these two events are independent, so let's start finding of probability of A intersect by B. So since we know that these two events are independent to each other, so in order to get this probability of A intersect by B, which is equivalence to probability of A times probability of B. So therefore this will be equivalence to 0.4 multiplied with 0.25, which this will be equals to 0.1. So for B, let's say that we are looking for probability of A union union by B. So the same rules that we're going to apply here. So if you still remember the rules of A union by B, which is PA plus PB minus with PA intersect by B. So since we know that these are independent, so we can say that PA plus PB will be minus with PA times with PB. Therefore, from here we can say that by putting all this value of PA and PB, we're supposed to have 0.4 plus with 0.25 minus with 0.1. So therefore this will be equivalent to 0.55. Example 2. A, B, and C are three events such that A and B are independent, whereas A and C are mutually exclusive. Given that probability of A is equal to 0.4, probability of B equals to 0.2, probability of C is equal to 0.3, and the probability of B intersect by C is equal to 0.1. Find A, probability of A union by B, B, probability of C given by B, and lastly, probability of C given by A complement. So let's start doing the A first. Okay, so let's say that we are looking for the probability of A union by B. Since we know that A and B are independent to each other, so therefore this will be equivalent to PA plus PB minus with probability of A times with probability of B. Then by substitute all this value, we're supposed to have 0.4 plus 0.25 minus with 0.4 times with 0.25. Then after calculate these values, we're supposed to have 0.52. Okay. Alright, then we go for B, whereby we would like to find the probability of C given by B. Okay, so the probability of C given by B will be equals to probability of C intersect by B divided by probability of B. So this is actually the formula how to find the conditional event when we have C given by B. Then we continue, we substitute the value. Since we have the value of C intersect by B, which is 0.1, we substitute directly. Then probability of B, which is 0.2, then this will be equals to 0.5. And C, we are looking for probability of C given by A complement. Okay, probability of C given by A complement. So using the same formula of conditional probability, then we're supposed to have probability of C intersect by A complement divided by PA complement. Okay, so since this one is actually we have A complement, as a previous lesson on my video, if you still remember, we have to solve using a Venn diagram. Okay, so we have to use Venn diagram in order to solve this problem. So let me draw a Venn diagram first. Let's suppose that we have these three events of A, B, and C. In this case, okay, A, B, and C, and we know that A and B are independent to each other. Okay, therefore by looking on this, I'm going to do the what we call this, the shaded region of the C and also and the A complement. So let's start with the A complement first. Means that I'm going to shade, I'm going to draw a region whereby it is outside of the A. So let's try to draw with A complement first. So this is actually the region of my A complement. Okay, then I'm going to start drawing a region for C. So let me use the color of green, representing for the region of C. So if you can see that the region that we're looking for in this case is actually in this part, whereby this is actually equivalent to C. Okay, since we are looking for the intersection, so therefore the probability of C intersect by A complement will be equals to probability of C. Okay, then we know that since we have probability of A complement, this will be equivalent to 1 minus probability of A. Then by substituting the value, we have 0.3 divided by 1 minus 0.4. So we have 0.3, okay, over 0.6. So therefore this will be equivalent to 0.5.